Students, good morning. Today I am going to give you a brief information on adiabatic reaction temperature. Before entering into this discussion, what is meant by reaction? Reaction is a process. Reaction is a process in which the reactants are converted into products. The reactants are converted into products. What is going on during this conversion? A simple definition, what is meant by reaction? Reaction is a process in which reactants are converted into products. Now my question is, what is going on here during this conversion? During this conversion, in the reactant side, there will be a breakup of bonds. Breakup of bonds between the atoms and molecules of the reactant. In product side, there is a formation of new bonds between atoms and molecules to give the desired product. Say for example, simple neutralization reaction. Sodium hydroxide plus HCl gives sodium chloride and water. This reaction we often carried out in our laboratory for acid-base titration. Sodium hydroxide is neutralized by hydrogen chloride. It will produce sodium chloride and water. There will be breakup of bonds for this reaction. Sodium hydroxide will split into sodium Na plus OH minus. And hydrogen chloride, there will be a split up between hydrogen H plus and Cl minus. During this breakup of bonds, enormous quantity of energy is required. It needs to break up bonds. It needs energy. It requires energy. It requires energy. Coming to the product side, the formation of new bond to provide sodium chloride, that means Na plus Cl minus. Formation of sodium atom and chlorine atom to provide bond between the sodium atom and chlorine atom to provide the new compound sodium chloride. Similarly, hydrogen H plus and OH minus. During the formation of new bonds, it releases enormous amount of energy. Okay. So product side there will be enthalpy change. Reactant side there is be enthalpy change. Similarly, product side there will be enthalpy change. Now my question is, what about the net enthalpy change? Net enthalpy change means difference between enthalpy of product and enthalpy of reactant. The net enthalpy change is the difference between enthalpy of product and the enthalpy of reactant. Okay, what? Right. The entire process is happen in a process vessel. The process vessel, what we call it as reactor. If the reaction is carried out in the reactor which is completely insulated, the reactor is completely insulated. That means there is no heat gain or heat loss. No heat gain or no heat loss with its surrounding. Clear? The net enthalpy change remains in the product stream itself. There is no chance to release the energy to its surrounding. So net enthalpy change, it may be two types. One is net enthalpy change. It may be positive value or it may be a negative value. Positive value means there will be a decrease in enthalpy. There will be a decrease in enthalpy. That means the temperature will be decreased. The final temperature, plus means there is a decrease in enthalpy. That means endothermic reaction. Endothermic reaction. In endothermic reaction, the final value, the final temperature is less than that of the initial temperature of the reacting system. If the net enthalpy change, its value if it is minus, what is called exothermic reaction. Exothermic reaction. That means it rejects energy to its product stream. Consequently, the final temperature of the reacting system will be increased. It is higher than that of the initial temperature of the reacting system. The temperature is called as adiabatic reaction temperature. Temperature of a reaction performed under adiabatic condition. Adiabatic means there is no exchange of heat. There is no exchange of heat. Changes in heat content is zero. Adiabatic. In such a situation, when a reaction is performed in a adiabatic reactor, the changes in temperature or final temperature is called as adiabatic reaction temperature. Temperature of a reacting system under adiabatic condition is called as adiabatic reaction temperature. That's all. Thank you.